In this video, we're going to look at multiplying a complex number by a real number and by I. So let's take this complex number down here, Z1. It's equal to 1 plus I. So what happens if we multiply this by, let's say, 2? 2 times 1 plus I is 2 plus 2i. And if we plot that, we can see that it is in line with the original complex number. If we draw a straight line to it, it will go to the origin. If we multiply it by 3, we're going to get 3 plus 3i, which again is going to continue this trend of it being in a straight line, and it's going to stretch it away from the origin. Okay, let's take the complex number 3 plus 3i and let's multiply it by a half. So we're going to get 3 over 2 plus 3 over 2i. So what's going to happen if we multiply a complex number by a number less than 1? So it's going to go from here, 3 plus 3i, it's going to go to here, 1.5 plus 1.5i. So it's contracting it back towards the origin. So these are the two things that you need to know in complex numbers about multiplying a complex number by a real number. When it's a number greater than 1, it stretches it away from the origin. When it's greater than 1, and when it's less than 1, it contracts it towards the origin. Now let's have a look at what happens when you multiply a complex number by I. So let's multiply a complex number by I this time. So something quite specific happens. So let's have a look what it is. My real and my imaginary. So let's take the complex number 2 plus I. And let's multiply it by I. So I times 2 plus I is 2i minus I squared. And minus I squared is plus 1, so we get 1 plus 2i. So plus I squared minus 1 plus 2i. So minus 1 plus 2i, let's plot both of these numbers. 2 plus I is here, and minus 1 plus 2i is here. So let's do a little diagram with the origin. So let's see what happens to this complex number. Now I'm going to join the two complex numbers together, and we're going to have a look at what this angle is in here. So look at my diagonal here. I'm going to do my red lines for the two diagonals of the two blue triangles, and you can see this is a 1 and down here is a 2. So if I just draw this diagram again, I've got a 2 and a 1, and going up this way for my second triangle, I've got a 1 and a 2. So both my diagonals are root 5. So in this new triangle, I've got, let's draw it out a little bit bigger, I've got a root 5 and a root 5. So what can I say about this angle and this angle? So we can't say they're 45 yet, but can we say this angle is 90, which is what we need to show in this question, that that these complex numbers, the first one will be mapped to the second one by an anti-clockwise rotation of 90 degrees through the origin. That's what we're going to show here. So let's have a look at these smaller angles inside each triangle. So this angle here, the tan of this angle, I'll just call it dot, is equal to 1 over 2. So this dot, if we get the inverse tan of 1 over 2, we're going to get 26. I'll round it off to one decimal, 26.6 degrees. And the inverse tan of 2 is going to give me 63.4 degrees. So angle 1 plus angle 2 is equal to 90 degrees. So therefore, angle 3, which is this one in here, is equal to 90 degrees with my three angles on a straight line. So you can see here, this one is 90 and the two dots are 45. So it's just a little explanation as to why it rotates through the origin at 90 degrees. So let's have another example of one of these to prove it. So let's have a look at multiplying a complex number by minus I. So if Z1 is equal to 3 plus I, let's put it here. connected to the origin. Minus I by Z1 is minus I by 3 plus I, which is minus 3I minus I squared. So this is going to give me a plus 1, so I get 1 minus 3I. So 1 minus 3I goes down to here. So we have Z1, and we have minus I, Z1. So again, is this a right angle? Let's have a look. So we take, there's loads of ways to do this, but if we take this 180 here, this angle and this angle are alternate. So would the top one and the bottom one be? And this angle is the inverse tan. We'll look at this angle first. I've got my 3 down the side, and I've got my 1 here, my 3 along this side. So we get the inverse tan of 1 over 3, and I'd have to add on the inverse tan. You can see here, this is a 3 and this is a 1. So this angle here is the inverse tan of 3 over 1. Now you get the inverse tan of 1 over 3 and it's reciprocal, it will always be 90 degrees. So you can see that my blue angle here has to be 90 degrees based on my straight line rule. So we can see that if we multiply a complex number by I or minus I, it rotates it through the origin at a 90 degree angle. Minus I goes clockwise, goes in this direction, and I goes anti-clockwise.